jet engines operate on a Brayton cycle of compression, combustion, and then turbine. Air is sucked in the front of the engine by these fan blades. It then moves through the engine, being compressed by the smaller airfoils. It then reaches the combustion phase, where fuel is added to superheat the air while pressure stays fairly constant. The air then passes through these turbine blades, which in turn turn the fan at the beginning of the engine. After spinning the turbine, the air passes out the end of the engine, creating thrust.
Here we're going to examine the pressure and temperature of air as it passes through an engine in the Brayton cycle. We're going to start at atmospheric pressure, 59 degrees Fahrenheit at sea level. Air is brought in through the fan to the fuel combustor. Pressure increases and temperature increases as well because it is compressed. At combustion, the small explosions of the fuel create a rapid increase in temperature, but a small increase in pressure. Once it reaches the turbine, pressure is released while temperature stays the same because the turbine expels the exhaust from the back of the engine. The process then goes back to the beginning, in which more air is intaken. Here we're going to examine the thrust of an airplane versus the time of its flight. Fn is a symbol for thrust and T for time. From the ignition of the engine at the start, the plane begins down the runway towards liftoff. This is the point where the plane departs from the runway. Through this time, we see a large increase in thrust in almost no time. At liftoff, the plane begins to lose some thrust for sound and safety reasons. As it begins its voyage, it will climb to the desired altitude. Here, throughout a large period of time, thrust increases only a little bit. After the voyage is over, descent begins, and the plane moves closer to the ground, therefore decreasing thrust. At touchdown, the plane needs to stop before the end of the runway. To do this, brakes are not enough. Thrust is reversed, meaning a mechanism is engaged to have the air be pushed the opposite way through the engines. This causes a spike in thrust and decreases speed rapidly until eventually reaching a stop. In the turbine, airfoils can reach temperatures of up to 3,000 degrees Fahrenheit, which exceeds the melting point of the materials. To solve for this problem, this area must be air-cooled. However, the less amount of air, the better. To solve for this problem, thermal barrier coatings have been invented that are sprayed onto the materials to act as an insulator, allowing less amount of air to be required to cool off the materials.
So an issue that jet engines run into is this intake fan spins at the same speed as the turbine fan. Now the turbine fan, to run at maximum efficiency, should spin as fast as possible. However, when the large intake fan spins at that same speed, the tips of the fan blades can reach supersonic speeds and generate large amounts of noise. To solve this issue, Pratt & Whitney invented a fan drive gear system that allows the turbine to spin at a faster speed than the fan.